Good afternoon. Welcome. This is Cindy from the Parkinson's Resource Center out of Spokane, Washington. Thank you to everyone here in Spokane and all of our satellite broadcasting sites today who have come to join us to hear Dr. Montine speak. And I want to say a big thank you to Inland Northwest Telehealth today, because we've had a change of plans of where we were going to have our speaker out of Spokane, and they scrambled in a good way and got connected and made it so that Dr. Montine could still speak. So I just really want to say a big thank you. We also want to thank some of our sponsors. Our Northwest Parkinson's Foundation is a partner in this with us, and they're in Seattle. And past supporters and current supporters out of Teva, Teva Neurosciences, Albertsons, the Empire Health Foundation, and all of our donors that are like you who come to this. So I appreciate your support in all the ways, and so does our board. Today we are here to hear Dr. Montine speak, and forgive me if I bungle any of the wording on here, but Dr. Montine is out of U of W in the pathology department, and he is the chair for the Nancy and Buster Alvord Endowed Chair in Neuropathology. And he is a professor and chair, I'm kind of repeating myself, for the Department of Pathology and professor for the Department of Neurological Surgery. Dr. Montine is a neuropathologist with expertise in Alzheimer's disease and Parkinson's disease, and received an MD from McGill University in Montreal, Canada. He directs a research lab that studies neurodegenerative diseases. And there are so many other things that I could read out about his experience with Parkinson's disease and neurodegenerative diseases, but I would rather hear you speak. Have you hear him speak today. So I am going to welcome Dr. Montine.
Thank you, Cindy, very much. Thank you for the invitation, and thank you everyone for joining in today. I apologize that I'm doing this remotely, and I look forward to coming and visiting you sometime in the near future. As Cindy requested, I've put together comments that will run for about 30 or 35 minutes, addressing several issues in Parkinson's disease. So to start, I'd first like to thank everyone who's funded our work. We're supported by the National Institutes of Health. They fund our center that we call PNUC, the Pacific Northwest Udall Center. That's a center for Parkinson's disease research, both in Washington State and Oregon, as well as our ADRC, our Alzheimer's Disease Research Center. And then, as Cindy mentioned, we've been supported by the Alvord family. We also have support from a variety of organizations. Some will be familiar to you: the Parkinson's Progressive Markers Initiative, PPMI, which is funded through the Michael J. Fox Foundation, as long as a variety of other worldwide consortia. So I'd like to speak on three topics today, all related to Parkinson's disease. First, what is it? Why is a lot of current research focused on diagnostics? And then finally, to mention progress in therapeutics, and hopefully, as we go along, to link all those three topics together. And then finally, before I get started, I'm obligated to mention that I'm a consultant to Eisai, Amgen, and General Electric, but I won't be mentioning any off-label medications or use of medical devices in this talk. So I'd like to start here, really, at the beginning. This photograph is the only existing photograph of James Parkinson, who was a physician in England, and in 1817 he published a very brief description of what he called the shaking palsy. And as all of you know, Parkinson's disease has this unusual clinical presentation where it's a mixture of too little movement, but then at the same time this tremor, too much movement. So that's what Parkinson was trying to describe, and that remains one of the very unusual features of Parkinson's disease related to all other neurologic diseases, that it's this unusual mix of too much and too little movement. It was about 20 or 30 years later that this man, Jean-Martin Charcot, who's considered the father of modern neurology, Charcot recognized patients that also had this unusual clinical presentation, and Charcot, not Parkinson, Charcot is the one that named this condition Parkinson's disease. And it was one of Charcot's students that drew this sketch of an individual in his care who had Parkinson's disease. And so this is the earliest known diagram of someone with suffering from Parkinson's disease. This was sketched somewhere around 1850 or 1860. And it will be, the features are familiar to many of you who either suffer with Parkinson's disease or have loved ones who deal with Parkinson's disease. The slightly bent over, this impression that walking has become difficult, and then the movement of hands, right? So we'll come back to this sketch several times as I move forward, but that's a brief overview of the history of Parkinson's disease, really first described about 160, 170 years ago. So if we remember this sketch and now advance forward to somewhere around 1910, was the understanding of at least the anatomical basis of Parkinson's disease. So this diagram is one that I lifted from an anatomy website, and we'll start here. This diagram is meant to show this plane of glass as if you could imagine we had a machine that could look just at that level through the skull. It would look like this, right? So here are the eyes, here's the nose, this is skull around here, and in this diagram we see the large lobes of the cerebral hemisphere, and then this structure buried deep in the brain is called the midbrain. And within the midbrain are these two dark structures, one on each side, one on the left and one on the right. They're called the substantia nigra. So if we imagine this part of this diagram now over here, this whole structure is the midbrain, and these two dark stripes are the substantia nigra. It's just Latin for black stuff, right? And these neurons are black because they use the neurotransmitter dopamine, and dopamine can form a pigment like what's in our hair and skin. So the dark pigment is normal, and what we see in everyone once they're a teenager. And what happens in individuals with Parkinson's disease is that the neurons that make up this black structure here degenerate. And so the anatomical basis of Alzheimer's disease, Parkinson's disease, which was described, as they say, around 1910, 1912, is that the substantia nigra loses its color. It's no longer black, and that's because the neurons that are in there have degenerated. And just to put this in context, there are billions of neurons in our brains, and the substantia nigra has relatively few. There are about 80,000 neurons total within the substantia nigra, about 40,000 here and 40,000 here. So when those neurons degenerate, they leave behind this structure. It's called a Lewy body, and I'm sure many of you have heard of this. Parkinson's disease is considered one of the Lewy body diseases, and in fact, it's the original Lewy body disease, and it's characterized by the accumulation of these large structures within a neuron. So what I'm tracing here is the outside boundary of a neuron. There's some of the black stuff in that neuron, and then the Lewy body. And so the Lewy, in combination with degeneration of neurons in the substantia nigra and the appearance of Lewy bodies, those are the two hallmark anatomical features of Parkinson's disease. So now we'll step back from microscopic anatomy and return to the brain. So this structure here, the midbrain, and specifically that black structure right there, the substantia nigra, is the same as this small purple structure in this diagram. So that's the substantia nigra. So those dopaminergic neurons don't reside simply within the substantia nigra. They send projections out to other parts of the brain, and the major parts where they send them are to the striatum, and there are different parts of the striatum, and perhaps we don't need to get too far into that, but this is called the putamen, and this is called the caudate. So neurons in the substantia nigra project normally to the putamen and the striatum and the caudate, both parts of the striatum where they do their work. And when these neurons degenerate in the substantia nigra, when they degenerate in this structure here, the processes that normally go to these structures also degenerate. So what does that look like? I can show you in this image. So rather than this being a diagram, like what I've shown you previously, this is a positron emission tomography, or PET, image of two individuals' brains. So this individual is neurologically normal and volunteered to have a PET scan. And the probe that we're using in this PET scan is to identify the dopaminergic terminals in the striatum. And what's showing up as red, yellow, and then greenish is the signal for those dopaminergic terminals. So what we're seeing here in this orientation is the caudate and putamen, the striatum, that's lit up with dopaminergic nerve endings. And then here is the same method, but now a patient who has Parkinson's disease. And what we see is that those dopaminergic terminals, the red signal, is lost. So the anatomy of Parkinson's disease gets a little complicated, and I went into this in some detail because it helps to understand what goes wrong in Parkinson's disease. These neurons degenerate in the substantia nigra, and because of that, patients lose their dopaminergic input to the striatum, and this is the major cause of the symptoms of Parkinson's disease, that this dopaminergic input has been lost in these two critical structures. We'll switch back a little bit to anatomy just so it becomes clearer. These red lines are meant to reflect the dopaminergic projections coming up into the striatum, and they form synapses, which means where neurons touch each other and do the business of the central nervous system. These dopaminergic projections from the substantia nigra synapse on these neurons in the striatum, striatal neurons, and when they're lost in Parkinson's disease, these neurons in the striatum go from looking like this, which is how they normally look, to looking like that. So the key point here is that there are three major events that occur in the brains of individuals who suffer from Parkinson's disease. Substantia nigra neurons are lost and Lewy bodies form. Dopaminergic input to the striatum is lost, and because of that, striatal neurons change. And it's these first steps, the loss of dopaminergic input, that's responsible for the initial signs and symptoms of Parkinson's disease. And it's this change that occurs in striatal neurons that's responsible for the delayed events that occur in patients with Parkinson's disease. We'll come back to this sketch again by Gowers, showing a patient of his who had Parkinson's disease, and remind ourselves that when someone first presents to their doctor and is diagnosed with Parkinson's disease, there's a lot of time left in someone's life. So 10, 15, 20, 25 years, sometimes 30 years. So as you all know, individuals have Parkinson's disease, can have Parkinson's disease for many years, decades, right? So from initial motor diagnosis to late complications of the disease, we think in terms of decades. We all know this from either having the disease or loved ones, people who live with us that have the disease. There's another very important point, is that we now know, using tools like that PET scan that I was showing you earlier, that the processes of Parkinson's disease start 10, 15, maybe 20 years prior to someone showing up in a doctor's office and saying, I think something's wrong. So the broad sweep of Parkinson's disease is that it lasts several decades, and it's somewhere in the middle that individuals present to a doctor because they begin to recognize that something's wrong. There's good news and bad news in that, and I'll come to that more in a moment. But just first to review then what we now understand are the complications of Parkinson's disease. So as I said, the people first present to their doctor recognizing that there's something wrong with movement, or this is by far the most common way to seek medical help. And as you know, the movement problems can become more severe over time. Sometimes they wax and wane. There are medications that are used to try to suppress the movement problems, but overall, and as I say, the broad sweep of this disease, movement problems become more severe as the disease progresses. But it's not simply a disease of movement. As many of you, I'm sure, are aware, there are abnormalities that occur in patients' sleeping pattern and in autonomic function. And it's now recognized that these abnormalities can precede, right? So if movement abnormalities start here, abnormalities of sleep, smell, the ability to smell, and autonomic function can occur years before there are abnormalities in movement. And not only those, but also changes in the speed and ability to think, which we summarize as being cognition. Changes in cognition are also clearly part of Parkinson's disease, and in a substantial subset of individuals, they begin prior to the onset of motor or movement abnormalities. So Parkinson's disease, we now have recognized over the last 10 years, is more complicated than simply abnormalities of movement, and that it involves abnormalities in other central nervous system functions, including sleep patterns, the ability to smell, autonomic function, and the speed and ability the facility with which we can think. The therapies that have been developed so far, and some of them are quite effective, the therapies that have been developed so far for Parkinson's disease are largely directed at relieving symptoms and largely directed at controlling abnormalities of movement. There are fewer therapeutic options available. I should say there are fewer proven therapeutic options available for abnormalities of sleep and autonomic dysfunction, as well as for abnormalities in cognition. And that's an area, a major area of research now, is to develop therapies that are more effective for these other features that are called non-motor, these other features of Parkinson's disease, not just simply motor or movement abnormalities. As I mentioned a few moments ago, the fact that Parkinson's disease starts many years before the onset of motor abnormalities is good news and bad news. The sort of glass half full, half empty, the half full approach or perspective means that if we can identify individuals in this period where the disease process may have started, but the individual is either not impaired or impaired so slightly that you can hardly notice it, if we can intervene at that period, we can do a lot of good. The trick to being successful in developing these preclinical therapies is being able to find individuals, and that's what drives the research now in diagnostics, right? By definition, individuals who have preclinical disease will not come and see their doctor and say something's wrong. No one recognizes that there's anything wrong yet. It's too subtle, right? So a major push in research is to develop tools that will help us identify people in this period so that we'll have an opportunity to treat before we get to this period where there are motor symptoms, sleep abnormalities, and cognitive impairments. So a word about diagnostics, not to get into too much detail, but this is an example of one of the diagnostics that we and others are trying to develop. So this is a laboratory test that we can use to try to diagnose Parkinson's disease starting before individuals become symptomatic. So here's an example of a protein that we know is important in Parkinson's disease called alpha-synuclein, and we're measuring it in spinal fluid of individuals that have Alzheimer's disease, who are neurologically normal, have a disease called dementia with Lewy bodies, which is a close relative of Parkinson's disease, patients with Parkinson's disease itself, and then a closely related disease of motor function called multiple system atrophy. And the idea is that alpha-synuclein is being abnormally deposited in brain in Parkinson's disease, and it turns out maybe in multiple system atrophy as well. And because it's abnormally deposited in brain, this fluid, cerebrospinal fluid that bathes the brain, sort of drains the brain, the levels go down. So individuals who are cognitively normal have higher levels. So an abnormal test is to have low levels of alpha-synuclein. Now, these are in individuals who have motor impairment, right? They've been diagnosed with Parkinson's disease. And our initial results indicate that we can also use this test to identify individuals who are preclinical, right, have not yet developed motor abnormalities of Parkinson's disease. So I'll return to our sketch here, the patient with Parkinson's disease. The major symptoms of the disease: movement, sleep and autonomic dysfunction, cognitive changes, right? Therapies that are directed at relieving symptoms, and our quest to develop preclinical therapies, and that will require sensitive diagnostics. So what are the symptomatic therapies that we currently have available? Well, there are several, but the major one, we divide into two major groups. The first group is drugs to replace either dopamine itself or to use a molecule that will copy the effects of dopamine. So I'm showing here the chemical structure of dopamine, and then this is another rendering of the chemical structure of dopamine. This is a small molecule. It's about the size of aspirin. It easily gets into the brain and is converted, used by those neurons that are degenerating into the neurotransmitter that they want, this neurotransmitter dopamine. So you can immediately see the problem with that approach. Dopamine replacement therapy works well so long as there are enough surviving neurons in the substantia nigra to use it appropriately. If you completely lack as the disease moves forward and those dopaminergic neurons continue to degenerate, the effectiveness of dopamine decreases over time. And I'm sure many of you have recognized that in yourselves or in loved ones. The other issue with using dopamine replacement therapy is that some of the complications that occur in mid to late stage Parkinson's disease, like unwanted twisting movements, that's in part a complication of using dopamine, and it's in part a consequence of those striatal neurons having secondary degeneration. So it's a complicated mix of the disease moving forward and the drug that we're trying to use to relieve the symptoms. So dopamine replacement therapy is one of the major therapeutic modalities for patients with Parkinson's disease. It's been used for many years, and it is effective. The other major advance in treatment for Parkinson's disease is shown here as a diagram. A gentleman who has a battery pack and then the computer chip here with the wires running and then going into the diagram here showing them going into his brain. This is meant to depict deep brain stimulation. Deep brain stimulation is a way of trying to rebalance an unbalanced system in the brain that's caused by this loss of dopamine. So the anatomy gets complicated. I've shown you two parts of it. The substantia nigra projecting up to the striatum, but then the striatum has projections to other parts, and those parts have projections to other parts, and the loss of dopamine unbalances that system, and that is a major cause of at least the motor and some of the cognitive abnormalities in Parkinson's disease. And deep brain stimulation is a way of trying to rebalance that system. It doesn't stop Parkinson's disease from progressing. It doesn't really cure anything, but what it does is bring, in some cases, profound symptomatic relief by rebalancing the system. We know that this works effectively, at least in many individuals. Deep brain stimulation works effectively on the movement problems that occur in Parkinson's disease. How effective deep brain stimulation will be on sleep and autonomic dysfunctions is not clear. There's some evidence that we can be hopeful that it may contribute there. And then it remains really a question mark how effective deep brain stimulation will be in relieving some of the cognitive difficulties in patients with Parkinson's disease. So the summary of this is that we have drug therapies and surgical instrumentation that can be very effective for motor abnormalities. It's unclear, but it's some effectiveness, but less effective on sleep and autonomic dysfunction, and not at all clear that these therapies are helpful in the challenges that patients face in their ability to think, especially as the disease moves forward. There's lots and lots of interest in developing other therapeutic approaches to Parkinson's disease, including non-surgical, non-drug-based therapies. I'm sure you're aware of many of these. Increased physical activity and physical training of different types appears to be effective, at least for some individuals, and can delay the need for either drug therapy or placement of deep brain stimulators. And so there's tremendous interest right now in trying to develop these relatively non-invasive and in some cases uninvasive approaches that will bring symptomatic relief to patients. So with that, I wish to thank the individuals in the lab who do the work. I have the privilege of speaking to you. They have the privilege of working hard. And then to thank you again for your attention and to welcome any questions that you may have.
Thank you, Dr. Montine. It took me a second to get up front. I apologize.
No problem.
And I need to grab the list of all the locations. Just one moment.
Sure.
Okay, so I am going to start with Clarkston Tri-State Memorial. If you will unmute your microphone, and I know that when you checked in earlier, you said how many people were in, but if you let me know how many people are in and your question, if you have any.
This is Clarkston. We have 15 people. My question is regarding the stooped posture. Is that an actual spine defect, or somebody just gets used to that, or is there walking?
Thank you. Thank you for asking. So no, it's not related to an abnormality of the spine, of the bone that makes up the spine. What characterizes the movement abnormalities overall in Parkinson's disease is that they're very slowed right? And so the stooped posture that's common in individuals with Parkinson's disease is thought to be an expression of that slowness of movement. It's just extremely difficult for individuals to straighten all the way up. It's not an impairment, at least initially, it's not a physical impairment of the spine. It's the muscles that are controlling standing up straight.
Okay. Thank you very much, Clarkston. Any other questions? Okay. Coeur d'Alene, Kootenai Medical Center.
Any questions?
Well, I just have one. I read somewhere that it's not good to buy women's vitamins with metal in them because that metal in there connects with something in the brain and ruins the cells.
We couldn't hear all of that question, but it was a question about vitamins and the type that you shouldn't buy.
Right, the vitamins with minerals. She's heard that the metal and the minerals somehow affects the brain.
Dr. Montine, did you hear that question?
I did. So minerals and vitamins are critically important to health. And it is possible to take too many of them. But vitamins and minerals taken in the amounts that are recommended are healthy. They're not hurtful.
Thank you.
Thank you. And how many people did you have at your location?
Oh, we have 14.
Oh, welcome. Thank you. Okay. Colfax, Whitman Hospital and Medical Center. Okay, I'll move on. If you have any questions, we'll come back. Colville, Providence, Mount Carmel.
We have 4 at the moment, and we have no questions. It was a very educational talk, though. Thank you very much.
So thank you.
Thank you for joining us today, Colville. Okay, Dayton General Hospital, Dayton, Washington.
Hi, this is Dayton. There's just one individual here. The question I would have would be, my challenges currently are involving sleep difficulties in sleep, and reluctant to take a lot more medications, but could you comment on about sleep aids?
Well, I can, I guess in general, not knowing exactly what you're doing, but many individuals who start to have difficulties with Parkinson's disease describe a restlessness that accompanies sleep, so much so that it impairs their ability to sleep, and especially if they have a partner there with them, often the partner complains first. This is a complicated topic because there are sleep abnormalities that are common in the same age group that don't have anything to do with Parkinson's disease. So I guess my answer to your question is, one, sleep abnormalities in early Parkinson's disease are common, so that you should for sure seek medical advice on how to deal with them if they're preventing you from getting adequate sleep. But beyond that, it's a little hard for me to say exactly what to do.
Sure, thank you very much.
Sure, thank you.
Thank you for coming today in Dayton. We really appreciate it. Grangeville, Idaho, Syringa Hospital. Hello? Okay, again, if I've skipped you or missed you, I'll come back and we'll get questions and numbers in a second. Miles City, Montana. Okay, Moses Lake, Samaritan Healthcare.
Hello.
Hello.
Hello, is this Moses Lake?
Yes, it is.
How many people do you have?
We have 7.
7, thank you very much. And do you have any questions?
Yes, I have a question. Could you
Sure.
expand a little more information on the electrical probe device as to its usage, the term, and is its permanency, just in general terms, how extensive is its use? In broader general terms, I don't see anybody using it, but just a little more profound information, please.
Sure, happy to. So it's an interesting background to this story. You could wonder, how did anyone ever discover to do such a thing? And back in the early 1980s, there were some trials to use a cell implantation into the striatum as a means to try to replace dopamine. The investigators put cells into the striatum that were little dopamine factories. That turned out to work really well sometimes, and then not at all other times. And no one could figure out why that was, why sometimes patients responded really well and other times not at all. And it turned out that it had nothing to do with the cells that were being placed into the brain. It's what structures the surgeon damaged as he put the needle into the brain to deposit those cells. And if the needle damaged this part of the brain called the subthalamic nucleus, those were the patients that responded well. And so from that, we figured out that if you could suppress the activity of the subthalamic nucleus in patients with Parkinson's disease, it brought relief to their motor symptoms. And so from that, the next step was to use these stimulators. So the stimulators don't make the subthalamic nucleus more active, they make it less active. They silence its activity. And in doing so, for many patients, it brings a relief to motor symptoms. So you asked, how commonly are these stimulators used? I would say that they're fairly common. So a significant percentage of patients with Parkinson's disease are treated with deep brain stimulation. So if that's something that you would be interested in learning more about, I mean, it's certainly a mainstream therapy now. If it's something you would be interested in learning more about, then you can ask Cindy to put us in touch with each other, and I'd be happy to help direct you to an expert.
Dr. Montine, the percentage, when you said the actual percentage, our volume kind of went out. What was that percentage?
Well, so I didn't give a number because it'll vary by practice site and whether there's a surgeon that has expertise in this area. But okay. This is commonly used.
Yeah, and if you do contact the Parkinson's Resource Center, we can get you in touch, yes, with Dr. Montine, and there are other doctors and neurosurgeons in our area that do the surgery quite successfully.
Right. So thank you, Cindy. Yeah, just to underscore, I'm not a neurosurgeon, so I'm not referring you to myself. We'll just help you find people that have that expertise.
Thank you.
Sure.
Okay. Thank you very much, Moses Lake. Did you have any other questions?
I do.
Go ahead. Just 3 times. It'll do it.
Okay.
I can't hear you.
Okay.
Yeah, there we go.
Go ahead.
Now.
I was wondering, what can you do to stop the freezing in doorways and when they freeze?
Yes. Oh, I understand what you're describing. This is a major problem for patients for which we don't have a very good answer right now. So the research that people are doing around this topic is specifically related to what I was saying, dance therapy and physical therapy, to try to teach patients tricks for dealing with freezing, as you said, especially within doorways. This has a major impact on people's lives, for which, honestly, we don't have a very good response right now.
Okay.
And Spokane and Seattle both have different dance groups, and Coeur d'Alene has some different ones also. And if you want information about dance group and other therapies, again, let us know. I'm going to move on to Pendleton, Oregon, please.
now we're up to 3 people, and we have no questions, and it was a great topic. Thank you.
Thank you.
3 people and no dog?
Now the dog stayed home, I assume, with the owner.
Hopefully enjoying the beautiful weather down there. Thank you very much. And Pullman Regional Hospital.
We currently have 5 people with us now, and I have a couple of questions. One, I'm interested in the mode of action of Azilect or Sagilent, and also if there is any new information concerning the potential causes for initiation of the degeneration of the neurons in the substantia nigra.
So I didn't hear the first part of what you asked.
I would like to know if there is information, if you have information about the way in which Azilect helps in the treatment of the motion problems.
So there's a theory that what leads to the motor problems in Parkinson's disease is not simply a loss of dopamine. What it really is that dopamine and acetylcholine, another neurotransmitter in brain, are out of balance. And so one approach, if you think that's true, one approach is to replace the dopamine, and the other approach would be to modulate the activity of acetylcholine. And so that's the rationale for using that drug. And then you asked a question about something that was causing the neurons to degenerate.
Which initiates the degeneration?
Yeah, well, that's the $1 million question. So I have a very vague answer for you. So it's some combination of what you were born with, what's happened to you during your life, right? Environment, right? So it's what you've inherited, what your environment is, and then something about getting older. Those 3 things together conspire in some people to initiate the degeneration of these neurons. But what exactly the mechanism is from those 3 forces, we don't know the answer to that yet. We're furthest ahead in understanding the genetics, the inherited vulnerability. But what it is about aging and then what's called our genetic background, we don't really have a good handle on that yet.
Thank you.
Sure, thank you.
Are there other questions?
What causes nausea in taking these drugs?
Yeah, so that's, some individuals have problems with that. That's related to this autonomic dysfunction that I was talking about. That's what produces the nausea.
Thank you.
Oh, thank you.
Okay, thank you very much. We're going to jump over Spokane for just a moment and go to Tonasket, North Valley Hospital.
Hi, there's 4 of us today, and I have just a comment to make. I'm taking yoga class, and it's actually helped me very well because it helps me with my balance and movement, as well as helps me have more confidence, and also it helps me get sleepy. So if I do have a problem sleeping, that's what I do.
I'm glad to hear it. Thank you.
This is Cindy in Spokane. Can I ask, is that a yoga class for everybody, or is it a yoga class focused for Parkinson's?
My yoga instructor, she deals with Parkinson's, and she is here, works at Tonasket. Okay, I need to find a way to talk to you because I would like to put that information out there and find out how we can do one in Spokane. So I will find a way to get a hold of you. So keep that in mind, please. And then Walla Walla, Providence, St. Mary's.
We have no questions. There are 2 of us here.
Thank you.
Thank you for joining.
We'd like to.
I'm sorry?
appreciated the talk very much.
Well, thank you. We appreciate you making it to today. Okay.
Excuse me.
I'm not watching the screen, Dr. Montine, so sorry if I interrupted.
No, it's fine. I sneezed. It's the apple blossoms came out over the weekend here, and so I have a little bit of allergies to them. So.
Okay, now you're just teasing us, because Spokane, the snow blossomed here a little bit with the rain this weekend. So, okay, we have 20 people here in our audience in Spokane, and I'm gonna turn on our mic and see if there's anybody who has questions here in Spokane.
Okay.
We're in Billings, and we have a question.
Billings?
Hello.
Go ahead, Billings.
I see on the card that we received in the mail that the speech or the topic was going to be possible environmental triggers. Do you plan on covering that at a future time?
I'd be delighted. That's a complicated topic. The short version is that there appears to be something related to the environment that increases risk for Parkinson's disease. It's not clear that it causes it in anyone, but in some individuals, it appears to make you vulnerable. And so how large is that risk? Estimate is that about 10% of Parkinson's disease may be due to environmental exposures. What exactly are the environmental exposures? They have eluded us, despite 20 years of looking and looking to try to find the environmental agent. None has been definitively identified yet.
Thank you, and Billings has 4 in attendance today.
Thank you, and I apologize for skipping, but thank you for coming on.
We have a question in Port Townsend also.
Oh,
you can
Port
hear
Townsend.
us.
Yes, we can. Thank you. How many people do you have?
There's 7 of us.
Okay, and what's your question?
Can you remind us, please, the name of the protein that he mentioned that you use sometimes for early detection that you measure?
Sure, so that protein is called alpha-synuclein. SYNUCLEIN.
SYN. Try that again. SYNCL.
SYNUCLEIN.
Great. Thank you very much.
Oh, sure. My pleasure.
We're in Kirkland. We have a question.
Hi.
Hello.
Hello, Kirkland. Go ahead.
Question I have, is there an average lifespan of someone with early onset, like in the 40s?
Yeah, that's very hard to answer. So there is, but there's a lot of variation around that number. So it's somewhere around 30 to 35 years is the average. But as I say, there's a 20 to 25 year spread around that number. So for what that's worth.
Thank you, Kirkland. Can you tell me how many people you have? Kirkland?
We also have 6 here.
Thank you. I apologize for anybody I missed on my list.
There's Anchorage. This is Anchorage, Alaska. We have 8 people here, and I think we do have a question.
Okay, Anchorage, Alaska, welcome, and please ask your question.
Okay. Hi, I have a few questions. One of them is glutathione injection. On YouTube, we saw 3 Parkinson patients who could barely move, and then they took this $600 glutathione injections, and they were mobilized, dramatic difference in their movement. What do you know about that? And I've also read that there is a whole background of science on glutathione. You can Google it online. The government has provided information what glutathione directs their efforts on ailments. I have two more questions, but would you talk on that one, please, if you know anything about it?
Sure. So yeah, glutathione is a very small molecule. It's a tripeptide. It's normally present at relatively high concentrations in our body. We use glutathione for a variety of important biochemical processes. As the questioner correctly asked or pointed out, there is a very large scientific literature on glutathione, very large, and there's a substantial scientific literature on glutathione and its potential role in models. And that's the key word there, models of Parkinson's disease, not in patients with Parkinson's disease. So it's reasonable to imagine some form or formulation of glutathione as a treatment, but those questions have not been answered yet. So it is not, although glutathione is a very important biological molecule, it has not been demonstrated to be effective in patients with Parkinson's disease.
Well, I read some of the research on it, and it's pretty impressive. It addresses various autoimmune diseases as well as, I can't even mention it. It's beyond me. The scope is just immense. There's a lot of it.
It is. It's a very important molecule.
Okay, my next question is when you say you don't really know causes of Parkinson's beyond heredity, lifestyle, environmental factors, and so on. I asked our neurologist, his neurologist, about the best place to live, and he said where you can exercise every day. And we live up here in Alaska, and I'm thinking that this is very dangerous for anybody not having enough sunlight, and you're not as mobile. And I just wondered, is there a location where there's a lot of Parkinson patients populated in one area, and where is that? Do you have enough research on that?
Right, so are there epidemiologic clusters of Parkinson's disease? And the answer to that is no. If you discount some drug abusers in California back in the 1970s and 80s, they did form a cluster of Parkinson's disease that has been studied extensively. But we now understand what caused the Parkinson's disease in those people. And it was a molecule that they had contaminated the illegal drugs that they were injecting into themselves. So other than that very clear cluster, there are not robust clusters of Parkinson's disease where we can get important environmental clues.
Okay, and my last question is related to nutrition. We discovered that when my husband eats whole foods, salads, fresh vegetables, stir fry, avoiding protein, animal or plant, then his medication works better. But whole foods seems to spike him up. And any others, even if it's dairy products like ice cream or cheese, it just brings him down rapidly. So we're very careful to work with medication by eating only whole foods, pretty much whole foods.
But that's great. Sorry, I didn't mean to interrupt you.
Go ahead.
That's great advice, and everyone will be different that way, but you need to pay attention to other parts of your life, and what you eat and drink is a big part of it, and how that affects how well the medications work that you're taking. So that's great.
That's true, and the only factor that's missing is exercise, and I think that's what's bringing us down. And also, he doesn't know when to quit working. He's very engaged in a lot of hobbies. He's retired already, so we have to balance everything. But anyway, also we're researching, I think it's called Wakana, or some kind of food that has a lot of dopamine and fava beans. He doesn't like the smell of fava beans, so I don't fix that for him.
I agree with him.
We're resorting to a lot of non-invasive means of living, which seems to work well, and stress is at some times in our lives. But I appreciate how you discuss what's going on in the brain there. But I was looking forward to the environmental factors that could affect the Parkinson and bring it on. I know that since he's had 5 MVA, motor vehicle accidents, which all the doctors inquire about, have you ever had head trauma? And he has, none of them his fault. I believe that brought some damage to his cells there, killing them. What do you think of that?
It's true. A significant blow to the head is definitely damaging to neurons, and not just neurons, but the other parts that make up your brain. So whether that's directly linked to Parkinson's disease, that's not a direct link that any of us can draw, but certainly avoiding head trauma is a very good idea. Just like, as you said, regular exercise is a very good idea. A balanced diet is a very good idea, not just for your brain, for your heart, for your kidneys, for your lungs, for your whole body.
Thank you.
Thank you very much, Providence at Alaska. Thank you very much. And Spokane, we do have one question. Go ahead, sir.
Is this working?
I can hear you.
Okay. You mentioned, Doctor, you talked about the super early detection efforts that were going on, and you said if you could find a good way to do that, you give some helpful therapies. What would those be? I got the impression that there was something new you would be able to try or different than what you would do later onset.
Right. Thank you. I appreciate it. It's an important question. And so the two efforts run in parallel. One is to develop the diagnostics, whether it's a laboratory test or a brain scan of some sort, and at the same time try to improve our therapeutic options like we've been talking about with the other questioners. And the hope, right? And it's not simply a hope. With the history of medicine, think about cancer. The history of treating chronic diseases is that you have better success when you intervene early. And we used to think that Parkinson's disease started around the time that a patient showed up in the doctor's office and said, I have a movement problem. We now understand that it's starting many years before that, and we need to find those people so that we can start recommending interventions, whether it's dance and yoga, or a drug, or deep brain stimulation, so that we can recommend therapies earlier in the course of the disease, not in the middle of the disease.
So, Dr. Montine, does that mean things like getting on the Washington registry so that researchers and doctors can find out people who are willing to at least give their information? And then does it also mean if you think something's wrong, go to the doctor?
Yeah, so what Cindy's referring to is a registry that we run for the state of Washington, just so when there is a research study, and there are many different types, we know who is interested in participating. Right? We welcome participation of everyone who wishes to volunteer. And I think I didn't quite get all of the second part, but yes, if you think there's a problem, don't be bashful. Go and speak to your doctor.
I have a follow-up on mine. Well, do you think there's a different therapy, a different drug or something than what we know of now that might be helpful at that early stage?
Right. So is there a therapy that's specifically effective at early stage? No, not yet. Okay. There are many therapies that are in what we call the pipeline, right? So that's a metaphor, but there are many therapies that are under development, but it's not right for me to recommend them to you because they're not approved for general medical practice yet. And that's what I meant by going on parallel tracks, right? So we have this effort to develop diagnostics, and I take your point. So we develop the diagnostics, what are we going to do about it? But at the same time, we're trying to develop therapies that will be specifically effective early in the course of the disease.
I got you. Thanks.
Sure.
And just another question. It'll be just a moment.
Sure.
Thank you.
Yes, ma'am. This is Miles City. We'd have some questions.
Okay, just one moment. We have one question here in Spokane, and then we'll come back to you.
Yes, you're talking about therapy.
Is the U.S. leading in the therapy business, or is that overseas somewhere, or who are the leaders in coming up with therapies for Parkinson's?
Yeah, that's in a little bit of transition, I would say. The United States, the universities and biotech industry in the United States currently remains the leader in the world, but that's under some pressure because of the economic downturn. And how this will sort itself out over the next 5 years, I don't know.
Does stem cell research enter into this thing, or who are the leaders in that regard?
Yeah, so there's hope for cell replacement therapies for neurologic diseases, but at this point, I think it's more hope than reality. So that's definitely still a topic of research, and is likely many years away from general medical application. There are serious issues with how the brain is organized relative to other organs, right? So stem cell replacement therapy, for example, for cardiac injury or for diabetes, it's much easier to solve the anatomy problems of those organs than it is for the brain, where one part of the cell is 6 centimeters away from where its projection goes, and that projection has to go to exactly the right spot. That problem has not been solved yet for stem cell therapy.
Thank you. That was a good question. Anybody in Spokane? Okay, Miles City, you said you had a couple more questions?
Yes, ma'am. This is Miles City, and we had 13 today. And we have a gentleman here wondering where he could get some publications on some of the treatments for Parkinson's.
Cindy, do you want to take that one?
I will, yes. If you contact the Parkinson's Resource Center, and you can call me at 509-473-2490, or email me at center@SpokaneParkinsons.org, or one more thing, www.spokaneparkinsons.org. There's a way in each one of those to contact us and get information out to you about those therapies. And if I don't have that information on hand, I will find somebody like Dr. Montine or somebody else who can help us get that information to you. Do you need me to read?
What was that phone number again? What was
There you
that
go.
phone number again, please?
Yeah, 509-473-2490.
Okay. Thank you very much, and we appreciated your presentation.
Oh, my pleasure. Thank you.
Thank you for checking in. Now, if we have no other questions, if you want to stick around for just a moment, I have several presentations coming up in the areas that we broadcast that I'd like to give information on. If you would like to, I have one that's coming up in Richland that one in Spokane, one in Ellensburg, Wenatchee Valley, Alaska, and the Alaska is going to be in Anchorage, and then one in Seattle. So I can either give you all the information real quick, or have you call me if you would like information about one of these topics in your area. Feedback. Do you want me to go through all of them? Okay. Living Well with Parkinson's Disease is taking place in Richland, Washington, and it is on Wednesday, March 13th from 2 to 3:30 p.m. with Dr. Robert Hutchman at the Red Lion Hotel, Hanford House. And again, if you need any repeat of this, please call me at the number I just gave you. This next one is a performance where Dr. Montine talked about dance and other therapies. One of the groups we have in Spokane are the Tremble Clefs, and they do performances along with their therapies, and they are doing a performance at the Touch Mark on the South Hill on Monday, March 18th from 2 to 2:45. And what's really great about that is you can see where therapy brings people. They are out and singing and also making people aware of Parkinson's disease. And the next one is Ellensburg, and it's Dr. Christopher Rhodes, and it is mutual caregiving, building a team approach between caregiver and care recipient, and that's Tuesday, March 19th from 9:30 to 11 a.m. at the Hal Holmes Center in Ellensburg, Washington. And that one is sponsored by Northwest Parkinson's Foundation. And then the same speaker and the same topic will be speaking in Wenatchee at the Wenatchee Valley Medical Center on Tuesday, March 19th from 2:30 to 4. And then in Alaska, in Anchorage, Dr. Monique Giroux will be speaking Tuesday, March 28th, my son's 16th birthday, our youngest one's. That's going to be quite a day. And that's at the U Tower of Providence Hospital. And again, Tuesday, March 28th, 2:30 to 4 p.m. in Anchorage. And then finally, understanding Social Security disability and how and when to apply. This is kind of focused to early onset, young onset who are finding that they're not able to work. And it talks about qualifying for Social Security. And that is Saturday, April 27th from 10:30 to noon at the Greenwood Senior Center in Seattle, Washington. And again, I went through those very fast, but there's a lot of really cool things going on, and wanted to give that information. So please call me or email me if you want more. And then remember, next month is Parkinson's Awareness Month, the month of April. We're going to try and do as many things as we can to bring about Parkinson's awareness. And next month's telehealth will be a panel of speakers. One's a pharmacist, one's young onset, diagnosed at 31, and then several other people with Parkinson's or spouses to talk about their experiences and answer questions. So.
We're going to be selling cookies that shape like tulips. Maybe some penguins in there too. Wow.
And our founder's wife, Jackie, just announced that we are also selling cookies next in April for Parkinson's awareness, and so we hope that you can join us. We thank you very much.